Okay, so looking at this next question, so same thing. We are solving for the um, what was it again? The increasing, decreasing regions, maximum, and concavity and inflection. So I'm going to differentiate this to find my maximum points. Okay, so I'm going to differentiate this. So I get 2x minus 1 over x. And I want to know where that's equal to 0 to get any minimum points if they exist. So solving this, I'm going to get 2x minus 1 equals 1 over x. I'm going to get 2x squared minus x, and then that's going to be minus 1 equals 0. Okay, so this factors, I think that's going to factor to 2x plus 1 and x minus 1. Just double checking. Yeah, that's going to give us the factors. So I have a 0 at negative 1/2, x equals negative 1/2, and x equals 1. Now looking at the domain of this function, log x cannot be negative. Okay, so we know that the domain, I should just maybe state that here, that my domain is going to be x is greater than 0. Okay, so we can take this solution and we can say that that one is not relevant because it doesn't exist. So I'm going to do my slope chart here. Okay, so here's my f prime. At 1, we have 0 here. That's going to be my domain restriction. So at 1 I have 0. If I plug in into my derivative, okay, so I'm going to, let's say 1/4, I should have 1/2 minus 1 minus 4, so that's going to be negative. It's going down across. If I plug in like 2, that's definitely going to be positive, so there's going to be a minimum point there. Okay, and we should really expect there to be an asymptote because the log has an asymptote at x equals 0, so I'm kind of expecting something to look like that. Okay, we're going to solve for the concavity, so second derivative. Second derivative is going to be 2 minus negative x squared, so 2 plus x squared, and see where that's equal to 0. So x squared, well, this is not equal to 0 because 2 plus a positive is not equal to 0, so there's no solution. Okay, so there's no points of inflection. So if I just test the concavity of my derivative, I'm going to have positive concavity. So I'll write my concavity here, my second derivative. Okay, it's going to be positive concavity for that whole region. So when I sketch this graph then, my graph I would expect a vertical asymptote there. It's going to go through at x equals 1. I should actually calculate a coordinate. X equals 1, 1 minus 1 minus 0. So at x equals 1, y equals 0. So I'm going to have a point that comes through like this, touches as there, and going to go up like that. Okay, so that's what my graph should look like. It should have an asymptote here as well, and it's just going to go off to infinity.